Dear students, we have known this is a periodic table where 118 elements are arranged in a particular column and rows, which was arranged by Henry Moseley in 1913. From the previous semester, we know that the elements electrons are arranged in a particular orbits of their own. So, each individual atoms or elements having their own number of electrons. For example, boron has 5 electrons, iron has 26 electrons. These electrons are arranged in a particular orbits, which was based on 4 different rules which were given by Aufbau principle, N plus L rule, Honshu rule and Pauli's exclusion principle. Today we will see these 4 rules and we will understand these 4 rules. First one is Aufbau principle. It goes like this. In the ground state of an atom, the orbitals are filled in the order of their increasing energy. So that means for example, you can take lithium with the atomic number 3. So if you want to arrange the electrons, so proton and neutrons are at the center around which the energy orbitals are placed. When we are filling electrons into orbits, electrons will go in the order of increasing energy. That means orbitals which have lower energy will be filled first than higher energy. So lower energy orbital will be first filled. That is, this is the 1s orbital which will be filled first with the 2 electrons in the opposite spin. Then the next electron will be placed in the next higher energy level. That means lower energy orbital will be filled first and then higher energy orbital will be filled next. How do we know that these 1s, 2s orbitals will have lower energy? How can we find that the 1s orbital has lower energy when compared to 2s orbital or 2p orbital? So, to know this, we have N plus L rule. That is, from the atomic structure, we know that we have 4 different quantum numbers. That is, first type of quantum number is principal quantum number, which is indicated by N. The next one is L, that is azimuthal quantum number or subsidiary quantum number. The next quantum number is ML, that is magnetic quantum number. And the last one is MS, which is indicated by MS, which is called spin quantum number. These are the 4 different quantum number which we have studied in the first semester of atomic structure. These has their own significance. Now we are concentrating on N and L values, that is principal quantum number and azimuthal quantum number. N indicates the orbital number, that is, if you consider 1s orbital, N will be equal to 1, that is orbit number. If you consider 2s orbital, N will be equal to 2. If you consider 4d orbital, N will be equal to 4. So, we are identifying N value, but we should know about L value. So, L value can be given by, for s orbital, which is 0, for p orbital, which is equal to 1, for d orbital, which is equal to 2, for f orbital, which is equal to 3. By knowing these values, that is, these are L values. This indicates L values. By knowing these n and l values, we can find out the energy of the orbitals. That is, if you consider 1s orbital, I will write it here. For s orbital, L value will be equal to 0. For p orbital, L value will be equal to 1. For d orbital, L value will be equal to 2. For f orbital, L value will be equal to 3. For 1s orbital, if you consider n will be equal, as I said before, n value will be equal to 1. For s orbital, n value will be equal to 0. So n plus l value will be equal to 1. So just make a note. Next, we'll go to 2s orbital. N value will be equal to 2. For s orbital, L value equal to 0. The n plus n value will be equal to 2. Then we'll go for 2p. N is equal to 2. L value will be equal to, for p orbital, L value will be equal to 1. N plus L will be equal to 3. For 3s orbital, N is equal to 3. L is equal to 0 for s orbital. So n plus L value will be equal to 3. Next we'll go to 3p. N is equal to 3. L is equal to 1. N plus L value will be equal to 4. Next we will go to 3d. N is equal to 3. L is equal to, for d orbital, 2. N plus L value will be equal to 5. Then we will go to 4s. N is equal to 0 and L is equal to 0. Sorry. For 4s orbital, N is equal to 4. L is equal to 0. Then N plus L will be equal to 4. And for 4p orbital, N is equal to 4. Likewise, you can find out L is equal to 1. N plus L will be equal to 5. Now, we need to consider the lower value of N plus L value. We need to consider lower value of N plus L value. We have to arrange the electron from lower value of N plus L rule L to higher value, which is having lower value of N plus L rule, N plus N value, that is 1s orbital. So electrons will be moved or filled in 1s orbital first. Next, which is the next higher value, that is for 2s orbital. Which is the next orbital? 2p. Here you can observe 2p and 3s both are having same value of N plus L value. Then we should consider the lower value of N value. Which orbital is having lower value of N value? That is 2p orbitals. That's why electrons will be moved to 2p orbital. The next one is 3s orbital. Next, you come for 3p orbital. Here you can see 4s and 3p, both the orbitals are having N plus N value will be equal to 4. Then we should consider the lower value of N value, which is having lower value of N, 3p orbital, that is 3p. Next, we have to go for 4s. Electrons will be filled in the 4s orbital. because the next higher value of n plus n value is 4. Then we have to come for 3D and then 4p because 3D is having lesser n plus n value while n 4p is having same n plus l value, but the n value will be higher when compared to 3D. That's why then the electrons will be moved to 3D, then 4p. You can write it here: 1s, 2s, 2p, 3s, 3p, 4s, and then 3D, 4p. Here you will get 5s orbital. That is given in this diagram. You can see here. Here in this diagram, 1s orbitals will be filled first, then 2s, then 2p, 3s, 3p, 4s, 3d. In this way, electrons should be filled. That is given by we should consider lower value of n plus l value. If the two orbitals having same n plus value, n plus l value, then we should consider lower value of n should be filled first. Next rule is Hund's rule. That is, pairing of electrons takes place until each of the orbital has one electron, or pairing of electrons in the orbitals belongs to the same subshell. Note it down. Same subshell doesn't take place until each orbital belongs to subshell is singly occupied. That means if you consider beryllium with the atomic number 4, we don't have any problem because we know that n plus l rule and Aufbau principle, 1s2 and 2s2. Then if you go to higher atom, for example oxygen with the atomic number 8, we will fill 1s2, 2s2, 2p, 4. This s orbital doesn't have any subshells. That's why this can be filled. But when we come to p orbital, this p orbital has 3 subshells. That is px, py and pz. These 3 orbitals are degenerate or equal in energy. When degenerate orbitals are filling, we should distribute these 4 electrons in such a way that each subshell should be occupied singly, then the pairing of electrons will be takes place. Now we will fill single electrons in each orbital with the one spin, then the pairing of electrons will takes place. This is Hund's rule. If you fill like this, these are the degenerate orbitals. If you fill like this is wrong way of filling of electrons. This is the right way. First we need to fill one electron in each orbit, then the pairing starts when we are filling degenerate orbits. This is Hund's rule. Next comes to Pauli's exclusion principle. Here it goes. No two electrons in an atom can have the same set of 4 quantum numbers. You can consider any 2 electrons. These 2 electrons must not have same quantum numbers. 4 different. It should be dissimilar. At least one of the quantum number will be different for any 2 electrons in an atom. That is, or you can state Pauli's exclusion like only 2 electrons may exist in the same orbital. These must be in the opposite spin. To understand this, I will take the same example, that is oxygen 8. As we write an electronic configuration 1s2, 2s2, 2p4, we have filled electrons by using Aufbau principle and n plus l rule. These are the px orbit, py and pz orbits. We have filled electrons in this way. So any orbital can occupy 2 electrons with the opposite spin. If you write like this or like this, which is wrong. Any orbit can take 2 electrons with the opposite spin is the Pauli's exclusion principle. Here is also same, 2 electron with the opposite spin. Here we have to apply Honshu rule. Each orbital should take 1 electron because these orbits are degenerate. Then the pairing of electron will takes place with the opposite spin. Now I'll consider any 2 electrons of this. As we know, we have 4 different quantum number: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Now I am going to consider 2 electrons from the oxygen atom. Now I'll write 4 different quantum number for these 2 electrons. Now I am considering, let it be this. These are the 4 electrons. I am considering this electron and this one, px electron and pz electron. This is for px and this is for pz. What is the principal quantum number for px? This is 2px, 2py, 2pz. That's why principal quantum number will be same. What is the azimuthal quantum number for p orbital, which is equal to 1. Now I am going to write magnetic quantum number. It can take values from this ml. Magnetic quantum number can take values from minus L, 0 to plus L. What is the value of L? 1. That's why minus 1, 0 and plus 1 are the magnetic quantum numbers, which is in the x orbit. That's why it is taking minus 1. And the pz orbital, which is having magnetic quantum number plus 1. If you consider a spin will be equal to, both are in the same spin, that's why plus of. So you can compare these with n value. Principal quantum number will be same, azimuthal quantum number will be same, and magnetic quantum number you can consider which is different, and spin quantum number will be equal. At least you can consider any 2 electrons of any atom, at least one of the quantum number will be different. You can consider another 2 set of electrons and write the quantum numbers. You can find out that at least one of the quantum number will be different. This is Pauli's exclusion principle. With this, we understood Aufbau principle, n plus L rule, Honshu rule and Pauli's exclusion principle.